have a plane to catch.
Cool. Welcome to the last day and to my presentation about Lagoon. Lagoon is a beautiful island and we're going to explore it today. So all of you can choose a house of that picture. Andrea already chose one. So and then we all going to live there for a year long. No, that's not. No, Lagoon is an open source build and deploy system for OpenShift and Kubernetes with full Drupal support. Didn't have space on the slide, so the W4DS is full Drupal support. I made that one up. Yes, who am I? I'm Michael, or people call me Schnitzel. I'm the CTO of Amazy. Amazy is a company that has people all over the world. We host websites, we build Drupal websites, and we maintain Drupal websites. And yes, one of them is Amazy.io. And yeah, that's my email address. If you want to send me emails, free tickets to things, or rant, or tell me that whatever, I said something wrong, perfectly fine. Let's look a bit at history, or why did we even came up with Lagoon. Amazy.io actually hosts since more than 8 years. And in 2015, we re-implemented a local development environment that all our clients and all our developers used in Vagrant. Which was at the time was the really cool stuff and what everybody used. But then in 2016, yeah, it was just too much pain. It took way too long. Like starting and stopping took minutes, sometimes multiple, like half an hour to start the Vagrant. And yes, so we thought, okay, there should be something better. At the same time, Docker was really started to be in everybody's mouth. And we said, okay, let's try. So we implemented the local development in Docker. We're super happy with that, because the things were much faster, and of course we learned a lot of stuff about how Docker behaves, that containers, they can just die and come back, and the code is not there anymore, and things like that. And at the same time, if you went to my session yesterday about GraphQL and React, we had the first projects about decoupling. So we had to figure out how can we run a decoupled Drupal site with a node server running on the server side, so with server-side rendering and stuff like that. And that was a requirement that came from our build teams and saying, like, we want to run Node. There's a chair over there. We want to run Node also on the servers. And instead of like using our existing system, our existing hosting infrastructure that we had, which was built at that time on Puppet, we said, hey, why don't we use all that Docker knowledge that we had from the local environment? Why don't we try to run it in production? And we did. End of 2016, we went live with the first production site in Docker. And yeah, in 2017, we really liked it. It was definitely a lot of experience in learning how it works, but it felt good. It felt, and a lot of things that we saw at the same time where Drupal is going with like different Solr versions, Elasticsearch and things like that. So we finally be able to have slightly different infrastructure for each individual website. And also in 2017, a couple of months ago, we decided let's open source everything. And we had to find a name for it. And as you know, finding names is very hard. So I came up with Lagoon just as a code word internally. And then when we wanted to open source it, I asked my team, like, okay, how do we call it? And everybody said, like, well, it's called Lagoon already. So, well, I guess be careful of what code names do you give your projects. It might end up actually being your name. So today it's called Lagoon. But let's actually look a bit into that open source. Why did we decide? And so if we talk about proprietary hosting, one of the things I realized after a very fast time is like, why do we even do proprietary hosting? What happened in the past that somebody thought this is a good idea? Because let's look at the open source-ness of the Drupal hosters. They use Linux, it's open source. They use an operating system, I don't know, Debian or maybe CentOS or Red Hat, whatever, it's also open source. We have a MySQL, open source. An Nginx or an Apache, open source. We have PHP, again, open source. And we have Drupal, that is also open source. But there's the hosting platform. Who finds the mistake here? Where is it? Who can tell me? Why do we think that the tiny piece in between of a whole set, of a whole hosting stack that is completely open source should not be open source? So we said, if we build something new, we make it completely open source. That means all Docker images that are running anywhere in Lagoon are completely open source. You can look at their code. All service configurations, means Nginx, Varnish, MySQL, MariaDB, Galera, everything is in that same Git repository, and you can find it, it's there. All build and deploy scripts that we use to build Docker images, test them, push them, run them, all of that is open source. And also the whole testing infrastructure is open source. So you can run it on your own computer. If you want to build something, you want to change something, you can actually check if it still is running. And the next thing is Lagoon uses a lot of open source. So we use the power of Kubernetes and OpenShift, which is a Docker orchestration system currently used by almost every big company that currently uses Docker in production. It is based on Kubernetes or OpenShift. And we use that. We don't have to reinvent the wheel to do like a Docker orchestration system. Or Kubernetes also gives us the whole virtual routing, like virtual networks on top of containers. It gives us a permission system. It gives us a system for persistent storage. It can talk to AWS. If it's running on AWS, it can talk to the AWS directly and create new storage and stuff like that. It's all already there. Why should we even come up with the idea of saying we're going to build it ourselves? So we use heavily OpenShift and Kubernetes, and we will see later how Lagoon plays with the whole thing. Plus, we're using the Alpine Docker images. Alpine is a super small 2 megabyte operating system specifically built for things like containers, and we use them, and we use the official Alpine images. So we don't try to install PHP ourselves inside a container. There are people that are much better in doing that. There are people that are much better in doing that for MariaDB, for Postgres, for Node, for Python, or whatever. So we use them, and we add a little bit of things that we need on top of it, or adding it, and that's what we run. So let's look at how does Lagoon actually work. And that's a TLDR version. So you have something local, that is some code. There's a Docker images that you build locally. You push them to Lagoon, and Lagoon pushes them to OpenShift or Kubernetes. That's the magic behind it. And that was my session. Thank you. Okay, I actually had to look that up. What's the opposite of too long didn't read? It's too short, want more. Okay. So let's do the too short, want more. So locally, we develop with Docker Compose. So in your Docker Compose YAML file, you define your Docker containers you want. So you add your Nginx, your MariaDB, your PHP, your Redis, your Postgres, whatever you need, whatever your code needs to run, you do locally, you test it locally, you build it locally, until you're sure that everything is done what you want. Then you push that to any Git server in the world. Can be GitHub, Bitbucket, GitHub Enterprise, GitLab, or maybe you built your own. You shouldn't, but maybe you did. And so you can also use that. All it needs, a webhook. So every time that you push something, Lagoon wants to be informed with a webhook that just something has been pushed. So you want to run that. And now Lagoon starts. Lagoon, what it does first, it reads your Docker Compose YAML file. It looks at that YAML file and sees the same containers that are in there. Thank you, Michael. That you see in there, and it builds the Docker images the same that are in there that you also build locally. It builds the exact same ones. It then connects to OpenShift and configures to OpenShift, like it creates a new project for each branch. We will see that later in the demo. And it will push the images that it just has been built, they will be pushed to the OpenShift registry. OpenShift, in opposite to Kubernetes, comes with a Docker registry already. So we just use that one. It pushes them in there. And Lagoon will also configure the resources. Anybody that ever used Kubernetes or OpenShift knows there's huge, big YAML files that are needed to tell the orchestration system what should it do, how many containers you want to have run, and things like that. And all of that is Lagoon doing. So as a developer, you don't need to know how to configure OpenShift, how to write these YAML files. If you want, you can, but you don't have to. And then Lagoon actually connects to OpenShift and just waits. Because after that, OpenShift does all its orchestration stuff. So all the magic of the Docker orchestration, we hand over to OpenShift to Kubernetes. And then all that Lagoon does, it just monitors the deployment. It makes sure that everything that has been pushed in there, if it's running correctly and stuff like that. Plus, it also runs additional tasks that you might define. And then, if everything is fine, Lagoon informs you, the developer, back either via Slack or any other chat system, via email. It can send you a text message. It can even call you if you want. It can call you and tell you in a computer voice that you just deployed the production site. So that is basically what Lagoon does. So what we are doing is all the stuff in the middle. We don't try to re-implement any local development. We use Docker Compose for that. And we don't try to re-implement any orchestration stuff because we use OpenShift and Kubernetes for that. So now let's look a bit on how Lagoon is built, or how does the middle part actually work. We decided to completely build it in microservices. So instead of being one huge, I don't know, bash script or Golang or whatever you want to use, we decided to build it in microservices, in individual parts. We don't have to look at that individually. If you want to know more, come to the booth and I can show you each of them individually. But basically the idea is, because we want to build it in a way that you can configure Lagoon to your needs, you can decide which parts of the system you want. You can completely disable them, or you could replace them. Like here, up here, we have the Slack system. That is 50 lines of code that looks at all the logs of all the deployments and all these services here. They all create logs, and the Slack is just deciding which of them do I push to Slack. As I mentioned, if you want to do something with Trello that it calls you automatically, all you replace here is 50 lines of code and just point it somewhere else. If you think like, I want to, instead of all our logs, they go into Elasticsearch. If you want to disable that or don't need that, you just don't start these services, or you can replace them. So the idea is really that it's built for a system. Right now, a lot of the code is in Node.js. Just because that was the first implementation, it's probably not going to stay that way, and it may be changed in the future. But again, because we have it in microservices, we can much better replace that. Plus, also, if the whole part on the right side here is down, the left part doesn't care at all, because all of them, they talk with a RabbitMQ in the middle, and as long as that thing is online, you can still do stuff, and you can like change. You can restart your OpenShift cluster and don't have to be worried that deployments don't go through and stuff like that. The next one is Lagoon runs itself in OpenShift. Because it's microservices and because it's Docker, so you actually, to run Lagoon, you need an OpenShift in itself. Because it's the most easiest thing to run Docker, and we can eat our own dog food. And yes, you maybe think, wait, if it runs in OpenShift, couldn't it deploy itself? And that's actually how you deploy Lagoon. So you need a Lagoon to deploy another Lagoon. For anybody that has seen Inception, yes, it can happen. So whenever we eat our own dog food in Lagoon itself, all the configurations of how to run Lagoon is Lagoon itself. You can run it. The first is actually you run it locally first, and then you point it to another OpenShift server anywhere in the world, and you kickstart it there, and after that, it runs individually there. So we really try to eat our own dog food. Everything we do is actually given by Lagoon itself. The next thing we decided is we want to integration test that. What does it mean? Well, each individual service, like the Slack thingy, the thingy that receives the webhooks, the thingy that checks deployments in OpenShift, all of them have tests themselves. They are tested, they're unit tested, but we want to test the whole system as a whole thing, because if you just test a doorknob, if a doorknob works, you're never sure if you actually installed the doorknob at the right place. And that's the same here. A service in itself maybe is perfectly working, but in the whole system, it could destroy something or it could cause issues. So we use Ansible for that. Again, open source. So what Ansible does, every time that you create a new commit and you push that git commit to GitHub, or you can also run it locally, we start a complete new OpenShift and a complete new Lagoon for that commit. And Ansible will then create a new Git repository. So what we saw before, when the local stuff, it will emulate that. It will create a new Git repository and commit, in that case, for example, Node.js, but we also have tests for Drupal, we have tests for PHP, we have tests for other stuff. I'm using the Node.js code here. So it commits some code into that repository with a random string that is just generated randomly. And it would then tell Lagoon, hey, deploy that Git repository into the OpenShift that I just started. And then Ansible is just waiting. It lets Lagoon do its whole thing and basically checks if that random string has been deployed through the whole process. So it runs the whole thing, all the microservices together, work together, deploy the site, and makes sure that the code actually arrives at the end. And with that, we can make sure that everybody here can write some code, and you don't have to be worried because we will test the whole thing fully automatically. And not only the individual tests, but the whole thing. And that is the first time that I'm myself seen such a system that gives you the capability of testing everything from beginning to the end. And you never have to test yourself like, okay, did the change that I just did that change actually work? Now, what can we run inside Lagoon? Well, anything you can put into a Docker container. There is nowhere in Lagoon itself it actually has an understanding of Drupal or even PHP. It has an understanding of Docker. It has an understanding of OpenShift. So whatever you can put into a Docker container, you can also deploy with Lagoon. Right now, Lagoon itself needs Node.js. It has an SSH server. It runs Elasticsearch. It runs MongoDB. It runs Kibana, and it runs Logstash. And we have templates for Drupal and Node.js. So we have like Docker Compose templates for Drupal and Node.js, but as mentioned, if you can write your own Docker Compose YAML files, that's all you need to do. So right now we are pushing obviously Drupal because as a Drupal hoster, we have a couple of thousand Drupal sites that need to run Drupal. So that's definitely what we're focusing on. But Lagoon itself is not married or in any case bound to Drupal. So if you want to use Lagoon for something completely different, as long as whatever you want to run, you can put in a Docker container, and that's pretty much everything right now. You can run it in, it even has support for Microsoft. So you can run a Microsoft Windows Server Docker thingy in OpenShift or Kubernetes. So if you want to run .NET things that needs Microsoft stuff, it would be possible. As mentioned, Lagoon is locally developed. So if you want to test, if you want to work on Lagoon and implement a new functionality or a new feature, you can run everything locally. There's a really cool tool called Minishift, which is diverted from the tool called Minikube. It's basically a whole OpenShift server on your local machine in a tiny VM that is running there, and you can test everything. So usually OpenShift clusters are multiple hundreds of nodes somewhere running to working together, but all of that you can run locally, started within like 2 minutes. You can just say Minishift start, and it starts a whole OpenShift locally so you can test it. We use Docker Compose, eat your own dog food again, for running the services. So the first time you download Lagoon, or you clone Lagoon, you just run Docker Compose up, and it will run it. And we have Ansible also installed locally, so it will also automatically be running in a Docker container. So you can do all that testing that I told you before that happens automatically in every commit. You can also run it locally to make sure that the things you wrote are actually working and they're all behaving correctly. So, who wants to see it? Okay. Cool. Okay, so the first thing, I want to show you, we start with an easy one right now. So we start with a Drupal example. So this is a Git repository that I, as a Drupal developer, would have locally running. And in there, I have a Docker Compose YAML file. And that Docker Compose YAML file has multiple containers defined. As mentioned, that is one of our examples, so you don't need to learn how to write all these YAML files, you can just copy them. But basically what we do here, we define containers. Unfortunately, in Docker Compose they're called services, but that was their choice and we're happy to live with that. So we have a CLI in there, we have an Nginx in there, we have a PHP in there, and we have a MariaDB there. Pretty much the minimum you need to run Drupal in local. There are some additional definitions in there. One of the most important one is that one. So this is how we actually tell the URL that I'm expecting the site to be accessible on my local computer. So if I copy that thingy and open it in and open it here, so this URL, actually docker.amazon.io, all is not pointing to the internet, it's actually pointing to my local computer, so that connects to the Docker container that is running locally. And in here, I have a full Drupal running. I can do whatever I want with that. So let's say I would like to move the Drupalicon around. So I'm taking the site branding, which is my Drupalicon, and I feel today, I think it should go into the footer. So moving the Drupalicon into the footer, no big deal, but at the end, it's just a regular Drupal that we all know, that we can run locally, that runs in Docker containers there. And yeah. Now, I actually wanna deploy that. So over here, let me go to the master branch. So I am in the master branch of my Drupal example, and now I want to commit that, and I want to push that into into an OpenShift. I want to run it, but I don't want to deploy it into the master branch because I want to first deploy it somewhere else, because I want to first show my team if they like the Drupalicon in the footer. So all I do, I create a new branch, and I say that is the Drupalicon footer. And the next thing I have to do, it's a Drupal 8, so I have to export the configuration. I can now connect into the CLI. So what I'm doing is I'm connecting into the CLI container. And in here, you can see this is my whole Drupal. And I have in the CLI, we have things installed like Drush, Drupal Composer, Drupal Console, things like that. So what I can run is like Drush text, which means I export the configuration, and we can see how all these configuration changes that are happening. And I say, yes, I want to export that. I go out of the container again, and in here, if I run, I can see all these changes in there. I can also look at them, so I can see how like I moved stuff around in my configuration. So I add that, and I commit that, and I say Drupalicon moved to footer. And I push that. And what's happening now, this is pushed to GitHub. And GitHub in here has a webhook set up that pushes that now to Lagoon. And Lagoon will start deploying. And in here we have the Slack integration activated. So we can see here, Lagoon just sent me that a couple of seconds ago. It sent me a new Slack message that tells me, hey, the project Drupal example just has been pushed the branch Drupalicon footer. This is actually the hash. I could click on it and it will show me, and that's the project. So let's click on that and see if it's actually what I committed, and that's really what I just committed. So what Lagoon is now doing, it creates a new whole Drupal site for that branch, because a branch has never existed before, and will run some tasks. So what it's actually running now, as mentioned, Lagoon is running Docker files. If we look in here, we can see how the Nginx has a Docker file the CLI has a builder Docker file, so there's a couple of Docker files in there, and let's look in them. So in here, you can actually define your tasks that you want to run every time, like a Composer install, because that's actually a Drupal 8 site, so we need to run Composer install, that is built with Composer. If you want to run any other thing, you can run yarn, you can run npm, if you have like Sass to CSS, if you want to run some other things. We have Nginx. The Nginx needs to know, because it's a Drupal 8 with Composer, so the web root is actually in a subfolder. We need to define that. So I just create an environment variable called webroot equals web. And like in PHP, in here, I can define like what PHP version that I want to use. Right now, I'm using the 7.0, but if I feel like today I want to run that on 7.2, and because I want to test it, I can just change that. We create that Docker images and you run it. And that means you can test individual branches with different versions of PHP. So if you want to test if 7.2 actually works, you don't have to change the master environment yet to another PHP version. The other thing we have here is MariaDB. There's no configuration there. We just use MariaDB version 10. That one is actually slightly configured already for Drupal, but there is a list of all Docker images we have. And if you feel, well, I really need another PHP module than the standard ones installed, you just add them here. We have documentation how to do that. It's not very hard. You can create additional PHP modules or do any changes to the images that you want. You can test them locally and you can try them out. So we heard now, okay, what is actually happening. Let's look into the part that usually is not visible by the developers. Because the developers, they run these Docker files, they write these Docker files, they test them locally. But let's look actually into the OpenShift. So what I have here, I have an OpenShift running that's running on one of the Amazee.io servers. So that is just for everybody that ever installed OpenShift. That's just plain OpenShift installation, nothing at all. In any case special. And if I go here, I can see that the Drupal example, there's a DrupalCon footer thingy here now. So when I click on that, I can see here in builds, there is a build running. So what Lagoon did, it received that webhook, connected to the OpenShift, and told OpenShift, hey, start a new container. The build is nothing else than just a Docker container that is running. And in here, it runs a couple of tasks. And these tasks, we have debugging enabled right now, so it's quite verbose. But what that thing does, it checks out your Git repository, looks at the Docker Compose YAML files, runs Docker build, and pushes all these images. And if I go over here to applications, I can see my containers that I defined before. I can see the CLI, the MariaDB, the Nginx, and the PHP. They're already there. They just have been created a couple of minutes ago. So basically, OpenShift will now start Docker images, Docker containers. So if we go like into the Nginx PHP in here, we can see we have two containers running. One of them is the Nginx, the other one is the PHP. They expose some ports. We have automatic tests. So OpenShift actually makes sure that the container is really working. So in terms of Nginx, we make sure that on /Nginx status, Nginx actually returns us something. So we just don't blindly start containers and hope they work. We test them before we actually go live with them. So all these things happen fully automatically. And when the build is done, Lagoon, as mentioned, monitors that, comes back and sends us a new Slack message saying, hey, that site is actually done. I can click on that and we can see here, my branch name is in here. So OpenShift created an automatic URL for that individual branch, and I can see now at the bottom there is my DrupalCon is in the footer. So I could show that now to my team. I could show it to somebody else and say, hey, is that what you wanted? Yes, okay, good. If that is what you like, then let's go back here. Let's find my Drupal example. So instead of just merging that branch now into the master, I want to create a pull request. So I go in here and I say I move the DrupalCon into the footer. I create a pull request for that. And guess what happens? There's a webhook. Lagoon realizes, hey, you create a new pull request. So it creates a whole new site again for that pull request. Because it could have happened that somebody changed something in the master branch. Your branch maybe is perfectly fine, but maybe something pushed something into the master branch. So the whole thing just happens again. And now we can actually look. So if we go back here, we have now a PR3 in there, happened fully automatically. And now we can actually follow it a bit closer. So we can see here the CLI, the MariaDB, the Nginx PHP, they just have been created yet. There's no code in them yet. And if we wait a bit, we can see that the Lagoon here, which is running, it is pushing some Docker images right now. So it's pushing the build Docker images. And the cool stuff is actually, because the code is exactly the same like before, there is no change. So it will use the same Docker images that we have created from before. So they're pushed in there, and now we can see the CLI is there. It started to deploy. It's already active. The Nginx PHP is running. If we look in here, we can see they're also running already, and it will just run the whole thing. The MariaDB is not pushed yet, so it will wait a bit more. So basically, that's happening all at the same time. And if you feel like, okay, well, now let's say that has been deployed, and the client decides, oh no, actually I don't need that. So what you do, you go into the branches, and your Drupal footer, we close our pull request first. So we do that, and we go to the branches, and we delete that branch, because we feel like the Drupal should not belong into the footer. And we can see at the bottom, Lagoon also told us that the branch has been deployed. So if we go back to our site that we had before and try to refresh it here, the site is actually gone. So it throws the whole thing away. So this is how you, as a developer, that is when you have Lagoon deployed into any system, in any OpenShift, that is the experience that the developers have. They just create new branches, push them up, get Slack messages, use them, and throw them away again, and can work with the whole thing. So let's say you like what you saw, and you want to try it out, or you want to actually use it. It's completely open source, so what do you need? Currently, as of today, you need an OpenShift. So Lagoon itself assumes that there is an OpenShift running. OpenShift is done by Red Hat. It's an open source tool. So they will explain you how to run OpenShift in any server of the world. There are example architectures for AWS, for Google Cloud, for Microsoft Azure. There is documentation how to run it in DigitalOcean. Plus, if you just want to play with it, you can use Minishift on your local computer to run it. You can also use Minishift to run it on any server in the world. Don't use that for production. It's specifically only for local. But you don't have to learn how OpenShift works to use Lagoon. And we have documentation in Lagoon that explains you how to connect the Lagoon into OpenShift, how to kickstart it, and things like that. So if you want to help, it's all on GitHub, amazio/Lagoon. And really don't worry, everything is automatically tested. So the system is a bit complex at the beginning because of the microservices, but just play with it. Try something and run the tests, and it will tell you if you broke it or not, or maybe you actually wanted to break it, or so you can check that. One of the things that we are definitely very interested in implementing is native Kubernetes support. So right now, it always pushes into OpenShift. OpenShift is based on Kubernetes, so a lot of the things we do are already Kubernetes-like. But as a Maze.io, we want to run OpenShift because OpenShift gives us the possibility of the higher security of running multiple clients on the same infrastructure. But if you're your own company, or your own team that doesn't have to worry that other people can have access to it, Kubernetes would maybe be fine. So if somebody is interested in helping with that, that's definitely cool. And as mentioned, there is no specific Drupal needs in there. So if you want to run other things, doesn't even have to be other CMSs, it can be anything else. If you're searching for a tool that automatically deploys you, come and help write the templates, write the Docker images, and let's contribute them back. Or if you have any other idea of things that you might want to do, you want to play with it, definitely just write either a GitHub issue, open a pull request, and let's work on it together. That's it.
Thank you.
questions, yes.
So I take it from just this slide and everything else I've heard in a few days. We're doing a Docker-based integration of Drupal and a Java system. So we can do that. We just have to provide the images and
Yes.
components.
There mostly, if you want to add a new system, there are two things you have to do. First is the Docker images that runs, like say, your Java code. Plus, we need to teach OpenShift how to run these Docker images. Like OpenShift needs to know, do you need persistent storage, which ports are there, which of the servers I can actually run multiple of these. Like there's some information, but if you search online, there is a ton of people that already run Java in OpenShift. So there are existing templates that explain how to run OpenShift in there.
Yeah, I know that OpenShift has support for Java.
Yep.
So in Lagoon, is there anything Lagoon specific that we have to do?
No. All that Lagoon does, it takes, it reads the Docker Compose YAML. It looks for, so if we go back here, one of the things so maybe another thing right now, a lot of things are called Amazy.io. They will all be changed to Lagoon, just because we started doing this stuff before we decided to open source it. So we will completely, next week we actually have a workshop at Amazy.io, and one of the tasks is to search through Lagoon and remove all Amazy.io-ishness in there. So that will be called soon, will be called like that. So in here we have a type, and based on that type, Lagoon searches for templates that are existing. And so what you probably would do here is say Java, and then you have a template inside Lagoon that lives there that knows how to run Java. But that's not something, you don't have to teach it, you just copy a template in there.
So is Lagoon then, would you say it's 2 weeks away from being able to do this? Or, I mean, as far as whatever you're going to do before it's fully released, is 2 weeks away, 2 months?
We run it already today. Yeah. Like it is running. You can take it today and you can start playing around with it.
So would you call it beta, or you don't want to call it? You don't want to.
One of the things that we realized when we started it, that the part of OpenShift actually caused some trouble. So if you look into the GitHub issue, a lot of people first struggle with actually running OpenShift and then connecting Lagoon to it. So what we're doing right now, and that happens just as a heads up. Oops, wrong client. So there is the master branch and there is the develop branch. And the develop branch now actually has specific installation documentation that explains you what do I have to do first in my OpenShift to do it. That currently lives in the develop branch. We will probably have next week a release that then goes over into the master branch. So if you want to play with it, use the develop branch and not the master, or just maybe wait a week and then we will have all of that done. We will also do all the Amazy.io to Lagoon changes. It's just a search replace, shouldn't be a big thing. So yeah, maybe 2 or 3 weeks, but after that you can definitely start using it. Yeah.
Question about the initial database import.
Yes.
You have like a source, you're grabbing the database to spin up the environments, and this is not shown in the local environments.
Yes, so that I skipped that part. So beside of the build tasks that we have, like the composer install or environment variables, you also have the possibility to do runtime tasks, or here we call them post-deploy tasks. Mm-hmm. So these tasks are executed by Lagoon inside the OpenShift containers for you automatically after everything has been built. And in that example, what we do is, so you can run in there, you can run bash scripts. So what we do is we check if, sorry, you have to look away, it's using Drush and not console. So we check if the Drupal is actually installed. But yes, you can also do that with Drupal console. And if not, we install a completely fresh Drupal, and then we import the configuration and we cache clear. And you can define like in which service you want to run that. Right now we run that all in the CLI, because the CLI is actually the only thing that has Drush installed. or all the additional tools. The PHP container is plain PHP. There's not even a composer in there. So you can define in which container you want to run stuff. And here you could write your own database import scripts. So you could say, I want to synchronize the database from an already existing site, or I maybe have somewhere an SQL file that I want to hear. What we do here, we run the config installer of Drupal. So we install a fresh Drupal site of an existing configuration. But you can configure that yourself, and you can also define it to run only in specific branches and stuff like that. Right. So it all will be happening here.
So this is all Lagoon-specific differential file?
Yes, that is a Lagoon.
Parses that and sends the command?
Correct. Lagoon parses that and runs the commands inside the container in OpenShift. Yeah.
So seems to be a lot of provisioning happening here, which goes against what Docker images are about, which is being immutable. Is there a concern with this? Because you do build images every single time. You do have this provisioning because you said the PHP container is vanilla PHP. So somewhere in there, you may run into the same issues like Vagrant eventually sucks because things tend to break over time. The same stuff that you run every single time,
yes,
eventually one day may stop performing the same way. That's why the provisioning component is a risky thing to keep in your system. You want immutability by building images and sticking to those pre-built images because they will never change.
Correct. But the idea is that we have upstream images that are automated. Like, we are not building, like, or we are not taking an Alpine from scratch, or here it was a CentOS test. We don't take them and build them from scratch. We just take the existing modules or the existing images and point and push our code in there. So yes, it could technically still break, but much less because you don't like reinstall PHP from scratch into the images.
Right, but still, if I want to install additional like PHP modules,
yes,
you'll have to fix the image basically.
Yeah, at some point. Well, let me rephrase the question. Is there any kind of registry where you push the images and
yes,
then you use those images
yes,
in production?
Yes.
Without rebuilding?
Yes.
Okay.
So OpenShift, I can show it to you here. So OpenShift has an image registry. Oh, I closed the pull request. So in here, we have a Docker registry running in OpenShift that is using these images, and it uses these images as layer caches for new builds. So, like if maybe I can show it to you here. So let's say I go back to the master, and I just, and I commit, or I create an empty push, and I push that deployment is going to take 20 seconds. Because it actually reuses the images that are already there. It realizes there has no code change been done, so why should I create a new Docker image? And it will reuse them. So if we go here, so we can see there's a push now, and a couple of seconds later we will have that, because it doesn't even replace the Docker, the containers, because it realizes all the images are the same, so I will not create a new deployment. So there is some reusability, but it is correct. If you add your custom stuff to the Docker files, the person or the team that is going to maintain it is then the person that actually added it. So we see now the deployment has been done after maybe a couple of seconds. But the cool thing is you can actually run it locally. So if I want to make sure that the build actually works, I just run docker compose build, and the same thing that happens during a deployment I can run locally and can make sure, and if there is an error I can look at it. Any other questions? Yeah?
Is Lagoon used by Maisie.io for current hosting, or this is something you're going to adopt?
Yeah, so we use it for all Node.js specific stuff, because that was the first part that we did. So we have all the decoupled things is all running, because that's the only way that we can run Node right now. The Drupal part we are now migrating over and over. We're first focusing on standard availability stuff, and then later we will focus on high availability with Galera clusters and stuff like that. If you look into the Lagoon, you can see already that we're working on Galera things and high availability stuff. Yeah.
And will there be a UI for like on top of OpenShift?
Yes.
Is it going to be open source? Because that's
Well, the last question, hopefully you can answer yourself. So yes, our idea is that the developer itself does not need to use that UI, because that UI, it's awesome from a system engineer for the people that deploy OpenShift stuff, but it's quite complicated. Like here you have deployment, stateful sets, pods, services, routes. There's no container in there. So what we are planning to do is to build a UI on top of that uses the API of OpenShift, but to abstract the system in an easier way. So that will happen at one point. It doesn't exist yet, but it's definitely something we're going to do. Plus, yes, it will definitely be open source.
So let me just rephrase an earlier question.
Yeah.
Sort of. If I jump into Lagoon in 3 weeks, are we going to be looking at a situation where future releases break old releases, or are we going to be everything is going to be unicorns and?
We will definitely document breaking changes and explain everybody how to use them. Because ourselves, we are running an OpenShift cluster in every country. So right now, we are starting OpenShift clusters pretty much in every data center that we have. And so it's not only just one that I have to upgrade, we have multiple of these that we have to upgrade. So writing good documentation in how to upgrade these will be essential. The next fun part is also OpenShift itself also has new versions. So we need to match them up. Like one of the new things is, you can see here, the stateful sets is actually inside OpenShift is a technology preview, how they call it, which is basically, well, it works, but we don't suggest it yet to use in production. Just a fancy name for the same. So we will also keep up with that and maybe release a Lagoon version that says now this minimum works with like OpenShift 3.7, which is something that comes out soon. So we will write documentation and when it breaks, how and what and not. So yeah, definitely.
Do you have to use the self-hosted version of OpenShift, or can you use their commercially supported one?
So OpenShift has 3 versions. There is the origin, which is the OpenShift. They have the container platform, which is the licensed version. And actually all our OpenShift are the licensed version. We don't use the origin. And then they have their own platform, which they call... I'm not sure how they call it. OpenShift Online, which is they run an OpenShift cluster for you, and you just pay per like CPU and RAM. We never tested it on there because that was never our plan to support that thingy. But we support the origins, which is the open source, or the container platform, which is the enterprise version. We support both of them because they have feature parity. So from an API point of view, it's no difference.
What does the container platform add on top of the open source? What is the difference?
The same people that work on the origin and the container platform, they work on the same. So the origin you can find on GitHub,
Right.
and a lot of times they come out on the same time with the same versions. It's just that the enterprise version creates, they do, can I say it? They backport patches.
Oh.
So like we had an issue that 3.5 had a bug when it was only fixed in 3.6. In Origin, everybody always said, well, it's in 3.6, so nobody cared. If you are on 3.5, you can now either update or, so if you use the container platform, they have longer support for these different versions, and if you have a bug in 3.5, they will send you a new version and they patch it. So that's the big difference. But from a feature functionality point, it's pretty much the same. And that's how Red Hat, how their model works. So that's like the difference between Red Hat Enterprise Linux and CentOS. It's feature parity, but you just get much better support and automatic backporting of patches and stuff like that. Yeah.
So I have a perhaps weird question. So we're really cheap and we run on all open source stuff.
Yes.
But we're also AWS. So if we wanted to run this on Red Hat on AWS,
Yes.
this doesn't need to be running all the time, does it? Could we like have a Lambda that just spins it up when we need it and turns it off when we're not using it? So because it costs a penny a minute to run Red Hat on AWS.
I mean, technically you can shut it down. I can't tell you how good it will work, but at the end it's just something that runs. I mean, OpenShift itself is Kubernetes, which runs inside Docker. So you can restart servers no problem. So yeah, you could shut it down from Saturday morning to Sunday evening and start it again on Monday morning.
I was thinking of like having a Lambda that just spun it up on demand. So.
We start OpenShift every time. Every time you test something, it starts a new OpenShift and destroys it. So it's definitely possible. I have not seen an implementation of that yet.
Okay. I'll let you know.
Yeah.
So this may be a salesy question. There's a lot of competition for Drupal hosting.
Yeah.
And Amazy is a bit of a newcomer compared to the older ones. Is Lagoon essentially the differentiation and the value proposition for Amazy hosting?
Yes, one point. That is definitely.
Are there others? Are there other differentiations there?
Well, because we can run in a lot more data centers than our lovely competitors, so that's definitely one. And we can also run. So we not only provide support for running it in a data center. What we also do, we do professional services to help you run your own Lagoon in your own data center. So if you decide I want to use Lagoon and you need some help how to run it and how to maintain it, we can do that on top of it. And the rest is, it's running on Docker. So far, we are the only ones that allow you to have your own Docker images running in production.
Okay, so going back to conversations we've had months before, we could deploy this in Azure, and that could be an Azure solution.
Yes, correct.
We will talk more.
Good. If you search here for OpenShift Azure.
I got one client who's really hot for Azure, and like, what the hell?
Yeah, so there are documentations by Azure itself how you start OpenShift Origin on Azure. You point to Lagoon there, and there you go. Okay, last question.
Thanks. So speaking about the competition, Aqua and Pantheon has been spoiling developers for years with fancy UIs and APIs and drag and drop and stuff. So developer teams are used to that.
Yes.
Is there any notion of that in Lagoon?
So right now, we try to focus on developers that like to work in the CLI, and if they wanna run an SQL sync, they actually wanna see which commands are actually running behind there. Like, is it running an SQL dump, or is it importing the database and stuff like that? And you can see all of that. We will build on top click, drag, droppy UIs that you can synchronize database and stuff. Right now, we try to focus on the CLI. That's what it is right now. We have definitely intentions to build a fancy UI, but right now we want to focus on getting the stuff done first. So we build everything API first. In Lagoon, you can actually see there is a GraphQL API. So you can also build your own UIs on top of it if you want to do that. But we will definitely have one at one point.
So is there a way to connect to particular Lagoon environment with, let's say, Drush? If I want to synchronize the production database to my dev environment and sanitize it, I do that with Drush?
Yes, you can. So what we have is there is an SSH server that is a wrapper around OpenShift. So you connect to that SSH server, and that server forwards you into a shell of the actually running container. So you can run MySQL dumps, you can run MySQL imports, you can run Drush remotely, all that stuff. That's there. Okay, sorry, I think we are out of time, but
Very quick question.
Come here.
Where's the best place to talk about this? Slack? Maybe
One sec, I can show you.
We have a public channel.
Now that I hear.
Yeah, we'll be moving to Rocket Chat soon.
Here, Gary.
Thank you. And thank you.